will be defining parameters. So major tool we'll be using here is Inventor, Autodesk Inventor. And we'll also be making use of iLogic to drive our models to achieve design automation. So one of the learning objectives would be I'll be showing you how to define your parameters. It's more or less like a demo. I expect you can develop on that. Then we'll be looking at how easy it is to use iLogic for basic products. You also learn logic and rules, what it means to have rule-based designs in your model and how it can help you drive design automation. Also, we'll be using, we'll be also looking at use of forms to drive configurations. So you see how it works. And one of the take-home I expect you to have at the end of the webinar will be to attain perfection, I mean, a relatively certain level of understanding of all these workflows. Then the aim is actually to reduce reworks, that's less mistakes, ensure that your customers are satisfied, and ensure that we get a fast code down to the system, just as it is on the slide, on the presentation you're seeing here. Then also, we're trying to also adopt design automation to increase employee productivity, reduce rework, higher ROI, that's higher return on investment, then seamless understanding between sales teams and the design team, then also high bid win. Now, statistics have shown that the early bidder always set the standard for subsequent ones. So it means that if you could get your proposal down, I mean, faster to the bid race, you tend to set a benchmark for subsequent bidder in the same project. So that's one of the things design automation will allow you to achieve. Then also, you know, when I talk about mistake earlier, human errors will be taken care of. Mistakes due to human errors will be eliminated because most of your designs are automated from onset. So then also disclaimer, we will not cover everything possible within the webinar timeline, but you get an introduction into it. Then there are many approaches to design automation using iLogic, but this webinar will show you just one method. So take note of that. So I'm not giving you the perfect way or the 100% route to doing design automation, but I'm showing you just one method. And mind you, there may be need to adapt this code in future as the technology changes. So you need to adapt this code for future technologies. Also, one of the keys to iLogic is know your process. That is how you want to use the model. So you have to have all those conceptualized, understand the process of the product you're trying to design. And I think with that, you're good to go. So these are one of the essentials of that you need to get ready when starting iLogic, when diving into design automations. I think I would make room for Julian now to call me.
Hello, good morning.
Oh, good morning, Julian.
Hello, good morning, everyone.
Good morning. You're welcome.
Can you hear me?
Yes, I can hear you. Go ahead, please.
Good morning, everyone. How are you all doing today? Welcome to today's session on custom product using design automation. So normally I was supposed to present today, and I will be doing a quick introduction into what we're looking at exploring today. So, you know, I'm already started. So you know, with today's challenge in the industry, when you talk about design, innovative design processes, we all are always tackled with that challenge of designing for best application, all right? Designing to fit, all right? Customization. Now, if you know, with the last industrial revolution, all right, with the last industrial revolution, the demand has always been mass production. However, with the current demands in the industry, we are shifting, we are transitioning from mass production to what we call mass customization. That means the taste of our customers are changing every day, all right? The demands are changing every day. And you know that with the demands of the markets, you beginning to realize that, you know, for every demand that your customer makes for you, there might be varying conditions, there might be varying parameters, there might be varying features that seems to change over time. Now, these things are beginning to be critical to businesses every day, as we have, for instance, during the COVID period, where you see that, you know, two different people might actually have a need, all right, of one particular product. However, the features and how the product work might vary. Now, this calls for a massive, massive turn to customization. Now, but when you look at customization, companies like, you know, that in this geography in Nigeria would have typically challenge with, you know, meeting the needs of these kind of customization. So when you look at a typical company, you know, in the country, you would wonder what reason would they be able to afford the cost of meeting every unique customer need? All right, would they be able to meet all these kind of demands per time, you know, and cost, when you think about time and cost? So, I mean, you might be, let's say, for instance, two people want Mercedes, a vehicle, right? But the other one needs a different option. The other one needs the car to be as flexible, maybe the seats to be of particular type, the wheels to be a particular type. Now, this becomes critical. Now, what we are about to explore today are innovations and technologies that can help companies meet this variable customization and still remain competitive and still win. Now, you know, there are so many options when we talk about automation, right? We are going to see awesome tools, also awesome workflows like logics, writing logics into your designs, such that, you know, per time you're winning even more. And then, you know, awesomely, I'm sure Felix will also discuss so much or something about some technologies that can even not just help you, right, meet these needs, but even help you to get even more with that few times. So I'm going to allow Felix and Bolowatife to go ahead. All right. So thank you very much, everyone, and it's nice having you here today. Thank you so much. You can go ahead now.
Thank you, Julian. Thank you so much. For those who don't know, Julian is the business development manager for manufacturing in Nigeria for Autodesk. So Julian, once again, thank you, and thank you so much. And we're always happy to have you in as we work together to lead the manufacturing revolution in Nigeria. So so Julian, Bolowatife, please can you pop and go ahead with some of the demonstration?
All right. So welcome back, everyone. Thank you, Julian, for the time. Then, okay, so some of the take home I would like you to also, let me just paraphrase what I said earlier. We're trying to utilize design automation to eliminate human error. And also, we're also one of the major benefit of the design automation, especially when you're using iLogic, Inventor, will be you'll be able to attain business level best standard practices. You'll be able to, because mostly design automations are well taught. I mean, if you're going to start a design automation process or project, these are said to be that you've thought out the whole process and you're putting into the design all the considerations that are necessary. So business level best standard practices are usually followed using design automation. So that's just the aim of it, that you're not leaving any stone unturned, and it captures the knowledge of you as an expert. So we expect professionals to actually take on doing more of automations, custom products, and being able to generate high revenue on the investment when you buy the software for your employer and for your businesses. And you get to win more bids when you can actually get your product out faster. And so I'll be showing you I'll be showing you how that is done in Inventor. And I have a demo of a tank, a diesel tank. I'll be showing you how easy it is to actually have your set up your parameters, set up your rules, and drive your model. So so let's start. So I have a tank, a model of a tank here, and this tank you're seeing here, it's actually it's been automated. I mean, not the form of automation, not an explicit automation per se, but it has gone through some form of automation. Then also disclaimer too, I'm not an hardcore programmer, so please mind me if my programming jargons are not conforming with some of the regular ones. I'm a core mechanical engineer with a level of expertise in design automation, especially using iLogic and VBA. So let me show you this. So I have the form here on the right corner. So I'm also assuming that we've gotten professionals on the webinar, and also enthusiasts and people who are already acquainted with this software. So there is no need for me to be showing you how the interface looks like, which interface is this. But I'm just assuming, so please bear with me if that didn't come in the course of the webinar. All right, so I've got the product update right here for this tank right here. So it's most of the sizes, the volume you have here is driven by these parameters you have here: the width, the depth, the height, the thickness, then the stand height. So I'll be switching from one to the other so that you can see. So I'm changing to a 1000 width. So it's a rectangular base tank. So more or less like a keyboard. So now what we are trying to do is we're trying to set up these. Why you have to have a product specification set up is so that if you're going to pass this design down to another party and you don't want them to actually go in and start changing parameters up and down, and imagine me having to go into every part and mix up this model and having to change all the parameters that drive them. It's going to be a lot time consuming, and some reworks will have to take place. And by the time I'm done, maybe I'm already too late for the bid, or I couldn't get it done within the set timeline. So my aim is to ensure that we could eliminate such. I'll reduce it to the barest minimum. So so major parameter driving these models are the width, the depth, and the height, as I said earlier. And if you see, if you change to a width of 500, just look below where you have the depth and the height. You notice there are changes there. Now, these are limitations I've set within the rules to actually limit what a salesperson or another engineer or any other professional, any other personnel would see, will be able to have control over. So they can't just have any irrelevant dimensions, any random parameter change, except the ones I have programmed in using my rules. I've declared with a rule. So now at the 500 width, you could only see the depth of 500 and 1,000. And the 1,000 width, you see a different depth, set of depth and height. And if you look below, you see the capacity. It also updates capacity for you to know the capacity you are upgrading into. So updating into. So now for the 1,000, which you have a depth of 500, 1,000, and 1,005, the height of 1,000, 2,000, thickness, sheet metal gauge, 3 mm, then the stand height as well. So this is just to restrict, put limitations, put some limits to help guide whoever is going to use this model, and they won't create anything out of proportion. And it will be a ready to go model for you to take on to BOM level, to production, and also to get a quick quotation out. So I will be going into the part one of the order and show you what it is. So if you look at here, I've gotten how many assembly files, just 2 assembly level at the main assembly model. So let's go into the assembly level 1. That's this one here. Now the first one here, that's the GCASM 001 is the stand. So now the stand is just, it's a sub-assembly of the main assembly. Now, one thing I want you to also understand is I'm trying to showcase the way in which you can actually start design automation from the beginning, but it's also easy. The norm we had when we're starting this kind of project is you have to start coding from the beginning with your parts and everything. But so sometimes you actually don't need to start the code from the beginning. Just have understand your workflow ahead of time, then you know what to do. So now this part that makes this subassembly that makes up the frame has just one part. Then I form the frame out of the Inventor frame tab here. So I just use the standard parts so that I'm not doing any sheet metal flanging for the frame. So it's just a standard part that you can find in the market and you could use on your design. So let me open the parts that makes up the skeletal structure of the stand. Now, here is the part right here. Now, if you look in here, I want to show you something. The iLogic tab is just by the model. Now, I don't have any rules in here. I don't have any form right in here at the part level. So I'm just freestyling my design by setting up all my skeletal structure systems and everything, joining the lines, creating my planes to drive the locations where the lines are placed. And I didn't have to put any rule right in here. So I just want you to know that you don't have to start with the rules. But now the most important thing at this level, when you're at this level of the part of designing a part, always declare your parameters properly. That's the most important thing. So that's the first thing I said we will learn here, declaring your parameters. So now when I'm starting the first sketch, if you look at the first sketch, I start with just a random, you could start with a random width, but understand where you're heading to. So I have the f_ depth, which is the name nomenclature for this parameter that forms the depth for the frame, and f_ width, which is the parameter that forms the width for the frame. So I'm going to just bring up the parameter dialog box, and you will see all the parameters that are declared right in here. So I have the model parameters are f_ width, f_ depth, and height, and they are 1,500, 600. So just keep designing, but understand that that you have to always declare your parameters to be able to have a clean design, and also nomenclature that you can take on to assembly and remember what it is. Now, these parameters are also linked to so ensure that some of the parameters that might not be much relevant to the assembly are also taking note of, like this one now. This is a brace. So I said brace B_height not. Now I'm linking it with the overall frame height, which is the brace at this level. So I'm making it a 25% of the frame height is what I make is where I put the location of the brace. for this one. And also for this one, I make it a percentage of the frame height. So this is 25% of the frame height. This is 25% of the frame height, while the other one at the other level is also a percentage of the frame height. So I don't want a situation whereby I have to go in and change the location of that frame height. So if the height is 1,000, the brace will be 25% of the height of the frame. So let's keep that. And so the first thing you need to put in mind is declare your parameters and understand them clearly. Now, so let's go into the assembly, which is the main assembly. Now, this is the level. This is the point where you now start. You put together all your frames. I assume you know how to do that. You insert frames, you link them, do the meters and everything, and you place them where they are supposed to be. Now, so before you now go into using a rule to drive this frame. So let me show you what the rules I've declared right in here. So the size rule. So what you could do is just add the rule. If you right click here, you can right click and you add the rule. You rename the rule, what it should be. So I won't be doing that. I'm just showing you what I did. So you right click and you add the rule. Now let's look at the size rule. Now, in the size rule, I'm gonna launch the size rule. I've gotten all these parameters already declared right in here. Now, but before you come in here to do all this, let me show you something you need to do first. When you have an empty assembly file, declare your parameter. First thing you have to do is declare parameters that you can recognize. So these are user parameters. They're not found in the assembly model. So I declare them from the understanding that I want to make use of the relevant parameters at the part level, which are the frame height, the frame width, and the depth, and the thickness that are very important to me to carry on to the assembly level. So you just declare your user parameter, and that's why I said you should declare your parameter and make sure it's something you can recognize when you're typing it in, because you won't have the option to go into the part and select it and bring it in here. So you just have to type it right here, frame underscore whatever it is. So I'm just putting something here because I've already declared that already. So you just do that right in here. Now, so once you've declared all your parameters, just declare them, put any value in the value region. Once you've done that, then you can now start setting up your rules. Now, so I'm going to go to the rules and set it up right here. Now, so with the rule now, so what you need to do now is you need to link the parameters in the assembly level with the ones in the part level. That's the main aim of what the rules are supposed to help you, so that you take control of every part from the assembly level. You don't have to go and open the parts. So you're just taking over the whole model from the assembly level, and you don't have to go to every part and change them because you're going to link them after all. So that's the main aim of this, of trying to automate the model, so that you don't have to go to every part and change them. So I don't have to rework on every part. If I have 2,000 parts, I don't have to rework them. So if you come in here now, you could see, so just let me show you how you could get your parameters and link them with what you should have, and link them with the part level, the parameters in the assembly, how you can link them. Now, if you look in here, let me just explain what this means first. Now, this is saying that the f underscore depth in the part level, if you look in the model tab here, we have the assembly, and it's showing us something similar to what we have in the model on the left-hand side on our model browser. We have the model browser also in the rule, edit rule dialog, which is also showing us the part that are in the model. Now, so what I want to do is I want to bring parameters in this part into the assembly level. Now, so what this is saying now in essence is saying f underscore depth in the part 0001 is equals to f underscore depth in the assembly, the one I declared. Now, if I have not declared this before, it will be if I've not declared this before, it will give you an orange color like this. I think that should be red. So it's going to show a color like this, which means this parameter does not exist in your assembly level. So it won't be blue. So take note of that one. So, but once it's blue, it means I've declared it. So that's why I said declare your parameters. First thing when you go into the assembly, taking them to the assembly, declare similar parameters that you can recognize from the parts, such that when you're actually setting up your rules, you don't have to, it will be able to give you a go ahead that it exists. But if it doesn't exist like this, f_depth usually doesn't exist in my parameter that I've declared at the assembly level when I came in here, but f_depth does exist. Now, so how do you get to link them together? Now, a quick way to do that is, it's actually straightforward. And if you look in here, I didn't have much lines of code. They're actually simple lines of code. Now, so a quick way to do that is if you go into these parts that we want to see the parameters I want to link with the assembly model. Now, so if you come in here, you click on the drop-down icon, then check the model parameters. You see the parameters right in here. So it's showing you parameters that exist inside this part, part 0001. Now, if you come in here and you double click on that parameter, if you double click on this parameter, it's going to show you, it's going to bring in the code. It's going to give you the function for that parameter right in here. So you don't have to cram parameters in on bracket, GC-PT. No, you don't have to do that. So you're not actually typing in every command in it now. But in case you want to know where this exists within the edit rule dialog, which is we have snippets on the left-hand corner that help you, that you could actually select them from and edit all these parts. So now, so after I've done this, I could just do equals to f_width, just as I had below right in here. And so these are what I did. I declare all the important parameters, which is the width, the depth, and the height. So let me show you where it is in the snippet, then we'll move on. So in the snippet, you go to the parameters right in here. Now, so what you should be, you're looking at for is the parameters in the assemblies. You want to link parameters in the assemblies with ones in the part. So if you come in here, you have parameter dynamic set list. This helps you set a multi-value list of an existing parameter, which is the width. So you don't have to go and set it at the parameter dialog box. You can set them right in here. We're going to get that soon. Get there soon. So let me show this one now. So this is equivalent to what I did before, where I clicked on this. It's equivalent to it. Now, but this is telling you what, it's giving you a sample of what you should do right in here. So it's saying part one of 1, D0, D0 is equals to 1.2. So what you expected to do is actually to come in here and replace this part 1 with the name of your parameter of your parts, which is GCPT 00001. So I come to this name here and place it right in there. Then the width also come into the model parameter and select the width right in here. So sorry, so I double click, I shouldn't have done that. So I can just put f_width right in here, then equals that to what exists in the that I've declared in the assembly model. So that's just that, and you can go ahead and declare all other parameters just as I've done, and that's how you declare them. So you can actually be linking an assembly file with another subassembly file. So main assembly can be linked with a subassembly or subassembly member also. So which we are linking parameters in the subassembly with another parameter in another subassembly. So you don't have to go to every assembly to change the assembly. You don't have to go to every part to change the part. You don't have to do everything. You can just once you've linked everything, you do them at the main assembly level. So that's that on that. So let me carry on, and we'll get back to questions. So please drop your questions in the chat section. Once by the time we'll round up, we'll go back and we'll take those questions from there. So now, so after I've declared my parameter right in here, I can now set the limit. So I'm setting the limit for the frame depth with respect to the width. So now I'm setting the multi-value list right here. Now, so you could just bring in this here, multi-value list dot set list f underscore depth. So what this means is the depth should have a multi-value list of 1,000, 1,500, 2,000. That's what it means. But let me show you how you can get to the multi-value list. If you come in here, you get to the get list right here in here. It says you come in here, it says sorry, just give me a minute. So you come in here, you get to the set list right here, and you select it. So it gives you a sample of what you should do. Now, these are parameters within the assembly level, not any parts precisely. So if you notice this, we've already linked all of them with the parts at this point. Now we're not dealing with setting multi-value list at the assembly level. So I can have the frame width set up in my assembly level. So you come in here, you change the D naught to F underscore width, just I have done below right here. I mean, F underscore depth, F underscore that, F underscore depth underscore height underscore width. So you do that and you make it whatever value you want to make it. Now, note that your unit is in millimeter, so you do it based on with respect to the units your model is. So you could change that to multi-value list now. So that becomes 1.5 and stuff like that. So I don't intend to do it all over again. So I'm just showing you what you're supposed to do, which is what I've done right in here. Multi-value list dot set list. Now, so what I have below here now is we're now setting the limit for the frame. So what I'm saying is this: I'm using a select case. Instead, it's also similar to if and else statement. If and else statement, the if statement conditions that we are familiar with. So select case is another way to actually not to say if this is that, else this. No, select case is saying that, okay, now for the cases of f underscore depth, for case of f underscore depth, which is this parameter. Now, what this case is saying is if it is 1,000, that's if it is this first one here, it should only show a multi-value list for the width. It should only allow you or the end user to see a multi-value list of the width to be 500 and 800 alone. You won't see anything other than that in the form. So what this rule is saying is it is restricting what you could have access to control. So you only see this multi-value list, you're not typing in your own dimensions yourself. So for case of 1,005, which is similar to what is here. So if it is 1,005, set a multi-value list for the width. Now, when I mean 1,005, I mean the depth of the frame is 1,005. Set a multi-value list for the width to be 800, 1,000, 1,500. Then if the depth of the frame is 2,000, you set a multi-value list for the width of 1,000, 1,200, then hence select. So you won't see any value beyond all these ones in the form, where by the time I set up the form or in the parameter. So once you're done with that, you hence select, then your update when done. So to set the multi-value list, I think I've showed you where to get the set list, where you can actually change all these parameters. Come in here, change it to what exists within the assembly, and you move on. So then here is update the document when done. It's also right in here under documents. You select so this, if you update when done, document update when done, right here, you make it true. If you say false, it won't run the rule for you. So once I'm done with that, it does that. Now I've set up a form that will allow me to be able to now start moving within the, So that rule, what I've been able to do with the rule is to set limitations. So I can now take up those limitations I've set with the rules and use them to set up my form. But just assuming we don't have a form yet, and you want to see what you've done, you have to come to the parameters, and if you look in here, I'm going to change. So I said I'm using it with respect to the depth. And when the depth is 500, it should show me multi-value list of, so just take note of this, 500 will show me a multi-value list of what? Just 1,500 and 800 for width. And the height, I'm not looking at with the height yet. But if you come in here, so just take note of it here, and let's go back to the rule so that you can see what we have here. So we have a depth of 1,000, 1,500, and 2,000. And we have a multi-value list for width right in here. For 1,000 is 500, 800. So you come into the parameter, and if you change that right in here, it's going to give you a new set of multi-value lists for your model, and it automatically updating it as well. So updating it to what you said, the limitations you've set for them right in here. But let me show you how it looks like on the form. It's better with the form because the aim is to have a user interface, the interface between you and the model, rather than you going into the parameters and doing too much right in there. So, all right, so let me quickly go through these, and we'll run up soon. So once I've done that, I could change the depth, if I change the width, if I change the depth right in here, it gives me a different option as I've set in the multi-value list. And when I can now select the ones I want to use for my model. So you see how it changes right there in the form. So let's move to the next assembly, which is the mean body right in here. Similar process in the mean body also. Now, why you're seeing it that way is because in a subassembly level, why you're seeing it like this is because I am working on a subassembly part of the frame. So it automatically it automatically break the link between what is in the main assembly level. But I could just click on this icon here. This is giving me a warning. Then it will do the updating for me if I come into the product update and select something within here. So it automatically go over to the subassembly and override what you have right in there, and it updates itself accordingly. So that's what it's doing. It takes a while, and that it is taking over the dimensions from that subassembly. So it's more or less like you controlling a subassembly with another subassembly. So let me move on to the next assembly, which is the body right in here, which is this one here. So similar process that we did earlier is what we're gonna do right in here also. Same thing, set up my configuration rules for every part that exists in here. 002, and link it with the parameters that I've actually declared right in here. If you come in here, I have my parameters already declared: the height, the width, the thickness, and the depth. So they are already declared right in here, and these parameters are already also are linked with the part, every part right in here. So I'm going to show you the parameter in the part levels as well. Now see, I have the width, the depth, the height, and the thickness. So they are already declared right in here. I'm just linking them at the assembly level to take control of everything. And there's no rules at the part level for these parts. It's only at the assembly levels that I have a rule taking control of all the parameters. So if you come in here, the same configuration you have with the frame is what you're gonna have right in here. And then you now set your multi-value list for the width, the depth, and the height. Then you set your case for the volume. So what I'm saying here is in the case is if I have a width of 500, it should only show me a depth of 500 and height of a depth of 500 and 1,000 option, and a height of 500 and 1,000 option, then thickness of 1, 2, 3, 4. So it's only going to show me within these options I've set it to be, the limitations I've set around it. So I had just two width, 5,000 and 1,000. Then right in here, also, there is a value that says S. If I have anything outside 1000 for the width, it should show me all the multi-value lists that I've set. It should go back to the default for all the multi-value lists that I've set for every parameter in the assembly, which is this one. So it's going to show me everything right in here once I've gone beyond 500 and 1000. So let me show you that quickly, and we move to the main assembly. So in the form, if you come in here, you see, so I've gotten 500 right here. So it's showing me all the parameters, all the options for the multi-value list for the width, which is 500, 1000. But when it's 500, it's only showing me options for a height of 500 and 1000, a depth of 500 and 1000, and thickness of 1, 2, 3, 4, as I've specified. Now, if I go to 1000, it's going to show me the options that I've set for the height alone, and the depth I've set for that width. So it's showing me the options for that, which is 600, and the depth of 800 and 900. Now, I said, then else it should show me all the available options. So let's go to 2000, because I didn't set any limitation to 2000. So what it's going to do is it's going to show me everything that exists right in here. Imagine somebody seeing all these options and is confused. It's just doing selecting everything, and this might not be manufacturable. So you want to set limitations to what another end user would be able to access, so that the end product of your quotation would always look nice. So that's that with this. Now, I don't think I need to show you how to bring in all this assembly and putting them together. These things, the normal thing you do right in here is just use your normal relationship, mates, flush, and everything to arrange them, then link the parameters. So let's go into the main assembly here. Now, in the main assembly, what I did is, I link assembly with sub-assemblies, similar to what we did by linking parts with assemblies. So you're going to link assembly with assemblies in the main assembly. You're linking a sub-assembly with the main assembly. So first thing I always, don't forget to always do, set up your parameters first. Depth, width, height, thickness, frame height, liters, the things you know that are important to your model, to drive your model. Then you come into the configure, and you link them together. The same process. You see, the codes are not different. They're the same thing I'm putting together. But the thing is this, I understand my process, that's all. So understand your process ahead, and you'll be able to achieve all this. And similar process, I link the assembly, it just changed the GC-ASM 001 with the width that I've declared in this assembly. Then if you go to the part, so here is the lead, which is the only part that I brought in from, that's not coming from a sub-assembly, it's just coming in on its own. Then I'm linking everything with the declared parameter in the assembly. And once you've done that, and you set up the limitation for the volume with respect to the width. So I'm using the width to actually drive the volume right in here. And that's all you have to do, similar process. And if the width that you're selecting doesn't exist, it should show you all the multiple value lists, just as I've shown you before. Then you set up your form. Now, I would have, the time won't be enough for us to start showing you how to set up form, but it's pretty straightforward. But I think we'll definitely make up order for showing you form some other time, when we'll be bringing your way other design automation process. So let me show you what this will do now. Now, if I change to the width, just as I've shown you earlier, a width, it shows me the available depth that I've declared, to use to restrict it from showing me relevant depth and height. If I have, so you're gonna see the depth, you can change it to 1000. It also shows you the volume. I mean, that's the capacity in liters. It gives you the calculation right in here. So you know what you are giving the client, and you can plan for any space that you have, and you don't have to go and change those dimensions individually. And for the frame height also, we change the stand height to 500, 600, depending on the overall height you want to achieve. And with that, I think, so let me show you the last one, which is when you do the 1,500, which will show you every other options that exist within the model, which you don't want an end user to have access to this. So see, it's showing you more options that an end user don't really need to see. And there's no limitation here. So it's showing you all the multi-value list you set up for the products. So I think this have done a bit of justice to what we intend to show you today. And in case you need us to answer any of your questions, please please drop them in the chat section, and I'll hand over to Mr. Felix to take it away from here.
Thank you so much. Thank you so much, Mr. Bulawatife Roland. That was an amazing section, and I believe that was also impactful for every single person that were part of this workshop webinar. And I'm actually going to quickly summarize and then add a few things, and then we'll take questions. First, I want to draw the attention of every single person here about the organization that is hosting this workshop today. This first, I know most of us doesn't know that most of us probably may have used similar softwares or possibly even Inventor, and we don't know that we could do a lot of customization and maybe a little bit of programming in Inventor and make sure that we could drive our programming and avoid repetitive tasks. So it's something that could cut off about 70 to 80% of the time we spend on a product trying to reconfigure or trying to redesign. So it's something that is very basic, straightforward, but a lot of us don't know. And sometimes it could get complicated too, depending on the number of parts and the configurations we need to do. And that's why we're all here for you. So with your generative card, this is one of the things that we love solving for our clients or our customers base. And then we're always trying to recommend solutions, whether software based, and because not all softwares have, even though you could use it for product design or mechanical design, has such capability to help us to achieve what we want. So in a type of consultancy and you know, advice and an aspect of deployment of software and all that, we help a lot in doing that for you, whether it ranges from the training services or engineering management consulting or technical support process consulting, because we are also authorized software resellers. So we get to consult for you when it comes to software, because there's a lot of softwares out there, especially Autodesk have over 200 software. So knowing what best works for you and your budget is something that is very, very critical. And how do you get to use these things? Because a lot of teams now work collaboratively. Some work from home, some work from different countries and all that. And how do you get to use these powerful and amazing tools to your advantage? So these are the things we're all here for, and we could all do that for you when it comes to developing plugins or customizable workflows for you to could actually deploy in your firm and all that. So it's something that we always, and then we always still also take a corporate training. So when it comes to advanced corporate training like this, we could set up such for you and have that coming into your organization and have deep down into what you need. And more still, we always do what we call discovery session to understand the customer needs, something that fits into your own specific and unique need, because it's not just running training that is just generic, but something that fits into you and then can actually bring return on investment for your firm, and then even increases the employee morale. So, and when it comes to product design and sourcing, we still handle that and a lot of other things, just like you see in our services. So we are so grateful for having you here today. And generative CAD services is still one of at fact the only design product development firm that actually pushes and for generative design in Nigeria. A lot of things are happening around that where you could just plug in and put in software parameters, and you could find a lot of amazing solutions coming up, and you could do a little bit iteration, just like we have here on the screen where my cursor is. You have there, this particular wheel was actually developed with generative design. So we're actually the ones leading that in Nigeria and even West Africa. So we're always happy to get to have that consultation and discussion with you. So back to the questions. So we would love to take your questions if you have any from you. Let's go back to the question section from what I have discussed here and or what my colleague have done already before now. So we're always happy to take those questions and then work with you. So first one, okay, someone was saying if you could get that the link of the workshop at the recorded video. They will try to, this is something we'll do for all the people who attended this. We're going to probably before Monday next week, we're actually going to send you the link through email, just like we did as a reminder in your email. So, and yeah, so questions and any questions or clarifications or things you think, a few things that you want us to let know, or you have ideas or you have questions from the section, please go ahead and share it with us. And we're always happy to. So, okay, Bashiru was asking how to get the part where the input parameter. So he's saying it was offline. So, okay, I think this could, this thing will be, we can go back at that point, but when you get through the video, since you attended the workshop webinar, you're actually going to find how that was done. So any other further questions, you could, just like you registered in the webinar workshop, you could have access to the email felix.amifule@generativecard.com or info@generativecard.com, or my colleague's email, roland.opoyemi@generativecard.com. So you can always reach out to us, and then we could have that conversation. We'll be willing to help you and your organization and a lot more. So I don't know if any of us want to have something to say, we could go on. I think Roland, still there? So you could unmute your mic and let's see what we could have a very brief summary.
All right. So thank you everyone for the time spent with us. So I will take you back to what we intend to achieve today, like I said earlier. So remember, one of the things I mentioned was define your parameters, very essential. And also I mentioned know your process. Is the process that helps you understand what you want to achieve. This model could be complex than this, it could be bigger, and the form of this, the depth of code you would have to write can be much more than this. So, but we don't want to bore you with too many of these things here, and if you need a special session, you can actually reach us via our email. And also ease of using iLogic for basic product, you know. Then the rule-based process, also we saw how it works, and also how the forms drive those configurations. Now, the thing is you don't have to go into every pattern and rework. You eliminate human errors. You take care of challenges that would have happened when you're doing, when you have to go into individual parts and then having to change them or modify or change parameters up and down. All you just have to do is link them. And most important thing is we want to generate our revenue with whatever we're doing, and we want our companies to also benefit from them as well. So this, if you can automate most of your designs, it helps you actually have more time to be more creative and do other stuff. Take on other projects with the time that you have to look at those. But most of the products that are standard product that you guys design in your firm or as a design firm or as a manufacturing company, you can actually automate those designs and just change configurations, and you don't have to go back to them again, except if you want to do some modifications to what you've done. So all you just keep doing is you keep getting better at what you've done before, while subsequently you could also have time to think of other creative ways to be more productive. So thank you. I think that's just one of the takeaways that I would like to drive around on this webinar.
Okay.
All right.
Yeah, thank you so much. Thank you so much. Bashiru was asking a question about training. So ask about offices. So we have about 2 offices, one in Lagos and one in Owerri. So it's actually showing on the screen here. So we could check us out. And then it's talking about training. So first, we always want to understand what the customer or what the client needs. So training, because it's in this level of advanced training, we always want to give what best suits and then add value to the organization or to the individual, other than just giving generic knowledge. So if we are for training, and yes, we can run online training with anybody, but for corporate organization, we always advise to have on-site training on their facility with their staff. So if you're looking for any inquiries and all, you can always reach out to us. I'm actually going to drop the email. You could reach out to us, and then we'll always be available to have more communication and then understand what you need. And then we can talk about pricing and the rest. So the email is in the chat section. I'm still going to drop another email. So in case you could send to any of these email, and then we'll always be happy to work with you. So in front of no other questions, and so thank you so much for being here today and staying to the end of this workshop. Well, we're hopeful that it made so much impact, and then it's actually opened some different innovative ways of how we could use your tools. You know, just like my colleague Bolabatife said, first, it's not all about the tool, it's about understanding what you're designing your product and the process. So always know your process and understand what the customer needs, and then the tool can actually help you out to achieve whatever you want to achieve. So thank you so much, and thank you once again. And from all of us at Generative Car Service Limited, we thank you for making our time to be here, and then we could always have more to do together. Thank you so much. So bye-bye.